Good morning. So the purpose of this first video is to get us kind of reoriented on tangent, clean up some things that we already know about it. Now in class recently, we looked at the tangent function. We looked at both the asymptotes of the tangent function as well as some information about the domain and range and that kind of thing, the independent and dependent intercepts. And what I want to do is to take some time today to talk about one other way that the tangent function is different than the sine and cosine function, and that's looking at Module 7, Investigation 8, problem number 10, which says the tangent function is periodic because it repeats on regular intervals, which is true of sine and cosine as well. But in particular, what is the period of the tangent function? And remember, the period is the amount of time needed for it to begin to repeat itself. So let's take a look at first the sine function. So here's the sine function, and we know that the time that it needs to repeat itself goes from the original, from this 0, 0, and then it follows itself, right? And then it doesn't start to repeat itself until it hits 2 pi, right? So that's where it starts to repeat itself, and then we keep going, and another 2 pi, it would repeat itself. So we know that the period of the sine function is 2 pi. So the question is, how long does it take for the tangent function to repeat itself? Well, we built it based on this starting right here, right? We were starting right here, and it zooms up, right? And then all of a sudden, it's down here, and it comes back up to center, and then it begins zooming up once again. So the question is, how long does it take for it to repeat itself? Well, it doesn't take a full 2 pi for it to repeat itself like it does for sine and cosine. Another way to look at that would be to take a look at what's happening on the circle. So if we look at this slope of this blue ray that I have here, if we look at the slope of this blue ray that I've got right here, and we follow it around, I don't know why it's not moving. Anyway, we follow it around, we can see that there is this dashed ray in the third quadrant that mirrors this ray, the slope of this ray in the first quadrant. So if I continue moving this guy around, maybe over here into the second quadrant, assuming that it behaves, well, that's not what I meant to do, pardon me. Okay, so if I take this piece right here and I look at what's happening in the second quadrant, then there's going to be another, here we go. There's going to be, so if I take this one over here and I look in the second quadrant, I can see that once again, there is a ray in the fourth quadrant that will share that same slope. So we know that each angle, as we look at the slope of each angle, the terminal ray of each angle, that it's going to be replicated in that opposite quadrant. So 1 is replicated in 4, 2 in, 1 is replicated in 3, 2 is replicated in 4, 3 is replicated in 1, etc. And so we've got this idea. But notice what these rays, these extended rays, these lines do, is they cut the circle in half. Well, half of a circle we know is to be pi. So that makes sense that when we look at the function itself, that it begins to repeat itself after pi and not after 2 pi. So we can say that the period of the tangent function is pi, unlike the period of the cosine and sine functions, which is 2 pi. We also already discussed where those vertical asymptotes are located and why they occur for these values of theta. Section 8, we technically have not talked about that yet, but you guys had that as your prep work for today, and we will sum that up tomorrow in class. If you are looking for some easy notation for that, you can look right here, and there's some easy notation right here for that type of thing. So don't need your hints. Thank you so much. But anyway, so we've got this different notation. This is one of the notations that we used for the domain, which is actually equivalent to looking at where the asymptotes are, that the domain reveals that. So we'll continue talking about that information in class. All right. Oh, actually, the other thing I wanted to talk about here, let's take that back off. The other thing I wanted to talk about here was this right here. We discussed in class the fact that the sine has these transformations. We've got when we add something to the entire function, it's a vertical shift. When we multiply something to the function, it's a vertical stretching or compression. When we multiply to the argument of the function, it's horizontal stretching and compression. So, and the same thing is true of the cosine function. All of these things are exactly the same. And if we were to take this information and we were to copy it over into the tangent function column, everything would be the same, except of course we would need to change this to tangent information. Okay, so there's our tangent. We have to change this one to tangent information. And this one to tangent information. And so, but the only thing that would change is that this guy right here, the period length would be pi over b instead of 2 pi over b, because we know that the period is actually only pi. So if we want to figure out the period length for tangent, we would divide pi by the speed as opposed to 2 pi, because that's what the period length is. All right, that's going to finish up this very first video. There's going to be a couple of others coming, and so I want to make sure that we're ready for that, and I'll post those just as soon as we are.